Today's lesson is over section 6.1, where we'll be talking about angle measure. This is in two parts. So part 1, we'll start with just the concept of an angle. Now, an angle has two sides, or two rays, met at the point we'll call the origin, because this is going to be on the coordinate plane. So the side that is always parallel, or like parallel with your x-axis, is always called the initial side. So we'll always start from this point, okay, or this array, when we're talking about angles in either direction. The other side is called the terminal side. Why it's called the terminal side is because as the angle opens up and stops, terminal meaning termination or terminate, so it's like the ending ray for, or the ending spot for the degree measure of the angle. Okay, you can have them going in both directions. When you're going counterclockwise, like this one is on the left, then that would be a positive angle. On this other side, when you're going in a clockwise direction, you have a negative angle. Okay. Now, for angles, they can be either in degrees or radians. Now, degrees are just normal numbers, 0, 1, 2, 3, 4, all the way up to usually in between 0 and 360 around the circle. If you think about going around, that's 360 degrees. Okay. Also, this can be written in radians, where you use a pi value to talk about the same thing. So once around the circle is also considered 2 pi. Okay. If you want to be able to change your measurements in between radians and degrees, we use a conversion where it's the value of 360 and 2 pi. Okay, so simplifying that, you get 180 over 2 pi. Okay, you also can orient the other way to get pi over 180. Okay, now when I want to change degrees, so like 75 degrees into radians, then I would need to use the pi over 180, because I want to be able to cancel out degrees. So to cancel it out, degrees would have to be in a cross cancel form for us. So like we could cross cancel the degrees out. So you're like canceling out a unit of measure, kind of like you do for unit multipliers or unit conversion. So now, if I multiply across, (75 pi over 180), so if I reduce this by a factor of 15, that gives me 5 pi over 12, which would be my final answer for that. Now, if I wanted to use or change radians into degrees, I would use the other one. Let me erase that. That should be just pi. Okay, so 7 pi over 12 times 180 over pi. So here in this case, the reason why I want this one is because notice that my unit of measure of the pi is in the cross cancel form, so I'm able to cancel them out and then able to multiply across. So 7 times 180 gives me 1260 over 12, and then I would divide to get 105 degrees, because this 180 has the unit measure of degrees. Okay. Now, there's another concept called coterminal angles. So let's say I have a certain angle, theta, and it gets me somewhere, let's say in the first quadrant. Okay. If I wanted to find a coterminal angle, I could go around the circle, or actually starting from this point, go around and get back to that, and do that a lot of times. So if I went around the circle like 10 times, I could still get the same angle. So you're getting it in the same standard position. Okay? Standard position means that you are, like, you have a certain initial side and a terminal side given making your angle. So if two angles have the same standard position, then they both share the same terminal side position with respect to the initial side to begin with. That's what makes them coterminal angles. Okay, so if I wanted to find one, I could either take my theta and add 360 however many times I wanted to. So I could do that for a value of k. So let k be an integer. So like any integer that you want. So like we could say, I want to go around the circle 3 times. So taking 360 times 3 and adding it to your theta would give you your new coterminal angle. I can also do the same thing by subtracting 360 and by an amount of k. So I can go in either direction to do the same thing. So using this concept, I want to be able to find coterminal angles, and if I have 40 degrees, then here I could add 360. So adding 360 degrees gives me 400. Okay, I could also add 360 twice or 3 times, so I need another 720. So then that would give me a coterminal angle of 1120 degrees. So that would be an answer as well. So there could be multiple answers for this type of question. If I'm doing it for radians, just like if you're adding 360, once around the circle is 2 pi in radian measurement, so I would add 2 pi. Here a little bit, you have to do a little bit more of common denominators to be able to add these, since they are mostly in fraction form. So then this would be the same thing as pi over 6 plus, if I multiply top and bottom by 6, that gives me 12/6. So then a coterminal angle would be 13 pi over 6. And like I said before, I can subtract. So let's say I took pi over 6 minus my 2 pi. So that's my 12/6 again. So that gives me negative 11 pi over 6. So these both would be answers. Okay? You can do certainly that for the same thing 4 degrees. Okay? Now, if we're on the flip side, let's say we have some angle, and we want to be able to get the coterminal angle that's in between 0 and 360. If it's a positive value, I need to subtract a value of 360 until I get in between 0 and 360. So for 1004 minus 360, that gets me 644. If I do it again, that gets me 284, which is in between 0 and 360. So I can stop and say that my coterminal angle in between 0 and 360 is 284 degrees. If it's a negative value, you would do the opposite. So I would need to add 360. So for negative 700, that gets me negative 340. And if I add another 360, it gives me 20. So here I would stop because I'm now in between 0 and 360. So my answer would be 20. You would do the same thing for radians, except you are either subtracting 2 pi or adding 2 pi to get in between 0 and 2 pi. That concludes the first part of section 1 for chapter 6.